So thank you for that presentation. I'm honored to be here. Thank you for the invitation to our sponsors, Hispanic Access and Renacer Foundation. So here I want to speak about my story, being an engineer from Colombian origins, and so space travel for the preservation of Earth. STEM and health science as pillars. My name is Francisco Paez, and I'm a manufacturing engineer who worked for Blue Origin. I work at the Cape Canaveral base. We're going to divide this presentation in 4 topics. First, my story. Second, we're going to speak about rockets as a system. We're going to talk about STEM science, and then we're going to end with a predefined activity. We're going to share a video of the mission of Blue Origin so you guys understand the title of this presentation.
New Shepard is just the beginning.
The first step.
From the very start, it's only been about one thing: Earth.
Earth, our Blue Origin.
We've sent robotic probes all over the solar system, and it's full of wonders: gas giants, rocky moons.
Earth is the best planet. It is not close.
Despite the variety, despite the wonder in the solar system,
There's no place like home.
Earth is our home, and there is no other place like it.
All life on Earth are uniquely matched to this planet. There's nothing like it anywhere else in the solar system, not even close, no way.
We have no choice but to preserve Earth.
Preserve this planet, this one.
we get to focus on the future, and the future is nothing without Earth.
For almost all of human history, Earth has seemed big.
It seemed big, but we now know it's small, it's finite. And we know that the rate that we're using Earth's resources is not sustainable.
Earth has things that we need to work on in the here and now.
But there are also long-term problems.
We can't wait to work on the long-term problems. We have to work on both.
One fundamental long-term problem.
We will run out of energy on Earth.
It's just arithmetic. It's going to happen. Humans have always used about 100 watts of power. That's our natural metabolic rate.
But in our developed technological society, we use over 10,000 watts of power per person.
Humans' use of energy is not actually a bad thing.
We live in an era of dynamism and growth.
There are so many good things that happen when we use energy.
Think about technology, transportation, hospitals, data.
As humans, we are at our best when we are inventing, when we are growing, when we are making progress.
But humans are doubling our energy use every 25 years, and that's unsustainable. Today, you could cover all of humanity's energy needs by covering the state of Nevada in solar cells. But at that rate of growth, in 200 years, you'd have to cover the entire planet in solar cells.
What can we do? Can we be more efficient? Yes, but we have been.
Today's technology is more efficient in nearly every manner.
We are gaining efficiency, and yet, when we gain more efficiency, what do?
We use more energy.
We have an ever-increasing demand for more energy.
So what if we just use less? Well, that doesn't work either. Throttling energy use means slowing down progress. You stop living in a world of abundance and you move to a world of scarcity and rationing.
There has to be another way.
There is another way. Space.
Space is full of abundant resources and energy.
Space is vast and practically limitless. If we can learn to harness the power of space and the resources of space, we can tap the limitless resources to help preserve this planet.
We can go to space for what we need. We'll make it routine, safe, and cost-effective to get there.
We will build the rockets and the destinations for doing real work in space.
We can do even more than this. We can move the most polluting industries from Earth into space where they can't hurt the Earth or the environment.
We can return Earth to a beautiful natural state. It will be like a garden, like a national park, a place for education, for creativity, and for recreation.
A place for enjoyment and for nature to thrive. In space, we can expand humanity. We don't want to leave Earth behind, but preserve it and expand humanity into space.
We can have 1 trillion humans in the solar system, which means we'd have 1,000 Mozarts and 1,000 Einsteins. This would be an incredible civilization.
Humanity will grow and progress and use energy for good.
Humanity can expand into the solar system by building destinations close to Earth, close to our home planet.
New places, places we haven't even dreamed of yet.
Places that feel like home. Places where great work can be done using the resources of space. An expanse that is meant for everyone, all kinds of people.
This is a hopeful future, an enduring human presence in space. Space is the long-term solution for Earth.
We're building a critical part of the infrastructure that's going to allow others to unlock
the road to space so that future generations can unleash their creativity.
It won't be easy. Space must become much, much more accessible to make this vision a reality.
Big things start somewhere, and that somewhere happens to be today.
There are certain gates we have to go through, certain prerequisites. If we don't do these, we will never get there.
First, we have to radically lower the cost of access to space.
This means reusable rockets.
We have to get really good at using rockets over and over.
Reusable rockets, reusable engines.
Once you learn how to do that, you can basically start spinning this flywheel where the more you fly, the cheaper it gets. The cheaper it gets, the more you fly.
Launch, land, repeat.
Going back and landing a rocket is really hard. And it is absolutely essential that we get good at that so that we can drive down the cost of launch vehicles.
BE-3, BE-4, BE-7, all made from the ground up to be reusable propulsion systems.
Operational reusability. That means making space travel as routine as air travel is.
This is what will radically bring down the cost of getting to space.
And we are bringing all of that learning to New Glenn, the next step of building the road to space.
Once you have low-cost access to space, the next gate becomes harnessing the resources of the solar system.
There are so many more resources up there in space than there is on our planet.
I mean, everyone's familiar with this idea of locally sourced goods, and this is just a really extreme version of that.
The moon is where we'll learn to do all this.
The moon has a vast quantity of resources.
And if we can learn to harness those resources, we can travel without stressing the Earth.
That's the goal. We'll go to space, and we'll use its resources to power our transportation and build destinations.
Anything we need, we will use the stuff in space to make it happen.
The moon is the next thing. We're going back.
It's time to go back to the moon, this time to stay. Make no mistake about this. This is not going to get done by any one generation. One of the things that we have to do is inspire those future generations.
This vision of millions of people living and working in space for the benefit of Earth is a very, very long-term vision.
It's gonna take generations.
We have to make sure that what we're doing today is setting up the next generation.
It's going to take all kinds of people.
Engineers, entrepreneurs, architects, artists, you, your children, your grandchildren.
This is kind of humanity's cathedral. You know, cathedrals took multiple generations of artisans and craftsmen and masons to build. And there was never the expectation that one person would design and fully execute the vision.
We have to inspire the next generation to carry this torch for the benefit of Earth.
For the benefit of Earth.
For the benefit of Earth.
We are Blue Origin.
And we will do all of this
We'll do all of this
for the benefit of Earth.
This video basically shares what I believe, what the company that I work for fights every day, and basically it shows the value of the mission. As Jeff was sharing on the video, is this generation, my generation, to build the road to space so that future generations go ahead and continue this journey. What are the three key aspects that we share in our mission is that we radically need to make it cheaper. We also need to, once we get there, we need to build this infrastructure. Once we build this infrastructure, we're going to have to go ahead and harvest the resources that are available for us out there in space. And then we need to inspire the future generations so this journey and this mission can continue. My personal story, I'm a first generation immigrant. I was born and raised in Colombia, South America. I'm proud as well. Applause for everybody. I grew up in a family of engineers and educators, people who believe learning could open a lot of doors. And I'm an industrial engineer by schooling and manufacturing engineer by profession. My career lesson is that every mission needs people who can turn an idea into something real, safe, and reliable. I initially started in 2004 working in operation manufacturing roles, and in 2007 it was basically I started working in like high precision manufacturing. Then I got the chance to get involved into multiple projects with the government. I worked for companies like BAE Systems, Lockheed Martin, and in 2019 is when I joined Blue Origin. From 2019 up to now, I've been building rockets as a manufacturing engineer. I started planning the bottom section where the engine fuselage goes. And now I'm part of the refurbishment team, which is basically once the rocket, the first section, that is the reusable section, needs engineers like me to go ahead and help the technicians to do the refurbishment so we can put it back in service. STEM, science, technology, engineering, mathematics. This is not just a topic or school topic. This is how aerospace is built or funded. We use the science to basically ask and understand what happened to the body, what happened to the materials when it's exposed to all these conditions. We use the technology, of course, to create sensors, software, robotics. Engineering is what basically helps us to design, build, test, and improve the systems. And we use mathematics to basically predict what's going to happen before it happens. The manufacturing engineer spotlight, it's basically where we move design into a tangible hardware. It's basically when we build something. What we have here, it's a top view of one of is what they call the high bay at the hangars where we build the New Glenn rocket. What we have here is where we build the midsection where basically all the propellant goes, the propellant tank. And what we have here in the back is where we build the top and the bottom section. I want to show you guys, compare these rockets to human landmarks, how big, how massive they are. This was the launch of the New Glenn 2. It took us, basically, Blue Origin was funded in 2000, and it took us up to 2025 the beginning of 2025, January 2025, to launch our first rocket. So it took 25 years for us to actually design, prove, build, and launch. So it's not an easy task. It's something that captures the different professionals in the industry. We work with, of course, with scientists, technicians, mathematicians, different kind of engineers, electrical engineers, manufacturing engineers, and health professionals as well when we have human missions. A little bit more in depth about the rockets. I'll try to speed up a little bit. So there's 3 sections. This is the SLS Artemis. What we have here from the fuselage up to this area is what we call the core stage, and from here up is what we call the upper stage. And then we have 2 solid rocket boosters that go on each side. The function of from here up to here is to basically to take the rocket up to orbit. Here on the New Glenn, similar but different purpose of rocket. Here we take humans, here we take payloads to space. There's 3 main sections. From here down is what we call the first section of the GS1, and from here up to here is what we call the GS2, and from here is basically a cocoon that carries the payload, which could be satellites or any type of probe that we're sending to Mars. The flight profile basically is this sequence of activities. They have to communicate to each other in a perfect timing. So we have the liftoff, the ascending. Here's where the separation happens. Here's where the karma line, where basically we start reaching orbit altitude. From here is the separation from the first section to the second section. The first section is going to do a reorientation of maneuver and keeps coming down and lands into the ocean in the Atlantic. The second section will continue its travel into orbit. Then it will open the PLF or the fairing, and then it will deliver the payload into orbit. Similar with the Artemis, here we have the launch and the ascending. This is the separation of the solid rocket boosters. At this point is where it splits from the upper section, and here when it reaches orbit and continues the travel to the moon in this case. Health science as one of the pillars of the mission. Health science is used before, during, and after the flight. Before flight, the health science basically helped to create this baseline, the need in order to have a good fitness, a good screening, in order to make sure that the astronauts, once during the mission, they don't experience any problem. During the flight, the health science helps the astronaut basically to track their sleep, vision, radiation, mood, performance. And after flight, there's a recovery of the astronauts, and it goes through all these exams in order to evaluate, after they get exposed to these conditions, how they are health-wise. These are kind of like the 5 hazards based on NASA related to the health science. It's space radiation. Up in the space, since you don't have the protection from the atmosphere, there's a way higher radiation. We have health science, the astronauts need to be evaluated about that. Then isolation and confinement, the astronauts are going to be for a long period of time on a spaceship. This creates a very high mental stress, which they have to be constantly evaluated and tracked. Distance from Earth, they're constantly evaluating how far they are in order to be able to use the protocols that they have in place in order that some emergency happens. The gravity fields, they test and evaluate how the low gravity affects their body, their bone density. The hostile, close environment, this is more related about they had limited resources during their mission. So they have limited air, limited water, limited food, and limited medical resources for any kind of emergency. So everything is being prepared ahead of time for all these kind of different scenarios. Some of the examples of health problems during missions. 1963, first American in the space, Mr. Alan Shepard. He was grounded for several years for a problem that he had in his ear. Apollo 13, Ken Knightley, I think everybody who have watched the movie have seen this, that he was removed from the crew right before the launch because of a problem that came up into his before the flight exams, something related to the German missiles or rubella. 1998, this being the oldest astronaut in space, Mr. John Glenn. He returned to space to study the actual effects of space travel into an age, so they can evaluate his balance, sleep, immune system, response, bones, muscle, metabolism, and blood circulation. A lot closer in 2024, the Crew 8 for the SpaceX. After the recovery of the crew, one of the astronauts, which it wasn't really disclosed really what was the problem, but he had to be transported directly to a hospital with some health issues that he had. What is the current reality right now with the health science and the missions in space? After 2019, well, technology came on board and the health science got changed with all these teleconsults. So after that, we see that everything is being not in person now. Everything could be over a computer. What NASA and Google are been doing is that they've been building these AI-powered crew medical officer. This has been designed basically for the long trips or long missions that are going to the moon and Mars. So anytime that they don't have communication with the astronauts, basically they have an assistant there that it could help them to, help the astronauts in the problem of an emergency. So Latinos in space, I just picked 4 Latinos, but I think there's 12 Latinos that came on board. These are, my picks for their importance to me. First one is Mr. Chang, Franklin Chang Diaz, first Hispanic American, 7 flights. So, this guy been to space many, many times. Miss Helen Ochoa, the first Hispanic woman that space. I think Miss Helen went in 2 missions. Very representative as well in 1993. In 2009, we have Jose Martinez Hernandez, engineer and astronaut. He went to a mission to the International Space Station. I think there's a movie about 1,000 miles away, which shares his determination from his humble origins to how to get to space. So that's one of my favorites as well. And not too far ago, 2023, Frank Rubio, Franklin, he, in collaboration with the international, he went to space through a Russian rocket to the International Space Station. Based on the problem that they have with that mission, with I think it's some leaks, he stayed in space 371 days. So he's been the longest person who has been exposed to the environments of the space. The message that I want to bring with this slide is that the Latinos is not only about the astronauts, Latinos and supporter stuff. It always goes to all these different engineers with specialties that goes into a mission. And I want to end with this message from my favorite astronaut.
I have one for you. Apollo 8 had a memorable Christmas Eve reading from Genesis. Do you have a message?
Imagine able to build anything just by thinking about it. Meet Base 44.
Message you'd like to share from space about Easter Sunday?
You know, I don't have anything prepared. I'm glad you brought that up, though. I think these observances are important, and as we are so far from Earth and looking at, you know, the beauty of creation, I think that for me, one of the really important personal perspectives that I have here is I can really see Earth as one thing. You know, when I read the Bible and I look at all of the amazing things that were done for us who were created, you have this amazing place, this spaceship. You guys are talking to us because we're in a spaceship really far from Earth, but you're on a spaceship called Earth that was created to give us a place to live in the universe, in the cosmos. Maybe the distance we are from you makes you think what we're doing is special, but we're the same distance from you, and I'm trying to tell you, just trust me, you are special. In all of this emptiness, this is a whole bunch of nothing, this thing we call the universe. You have this oasis, this beautiful place that we get to exist together. I think as we go into Easter Sunday, thinking about, you know, all the cultures all around the world, whether you celebrate it or not, whether you believe in God or not, this is an opportunity for us to remember where we are, who we are, and that we are the same thing, and that we got to get through this together.
Well, for someone who didn't have anything prepared, that was really quite extraordinary.
Very inspiring message from Victor. Let's go, I think we still have a few minutes left. Let's go back to the Q&A if we can.